All right, so to do a problem like this, first thing I want to do is it says use binomial expansion. I don't know. So what I'm going to use binomial expansion. But the first thing I want to do is know what are my coefficients going to be multiplied by. Because I notice I have some different terms than x and y, right? So by applying binomial expansion, I have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This was for the fourth degree, right? Yes? So we need to figure out the fifth degree, which is 1, 5, 10, 10, 5, 1. So these are going to be what every single one of my terms in my binomial expansion is going to be multiplied by. So that's to the fifth degree. All right? So I'm going to keep that 1, 5, 10, 10, 5, 1. So by using Pascal's triangle, that helps me understand that each one of my terms, as I expand this, I know that each term is going to be what it was going to be multiplied by 1, 5, 10, 10, 5, and 1. Right? Every single one of my terms. That's the binomial expansion from Pascal's triangle. Then, ladies and gentlemen, it's the exact same thing that we're going to do. We know that we're going to come down each one of these terms. This term starts at what degree? Because remember, each term can be rewritten as x to the n minus r times y to the r. So the first thing is we're going to say r equals 0. So therefore, my first term is going to be written to the fifth degree, right? Yeah. So what we'll have is, so what I'll do actually, we know we're going to have each term. So I'm going to have 2t, and I'm going to have an s plus. Actually, that's going to, yeah, it's going to be s. And then this one's going to be 2t negative s. 2t negative s. 2t negative s. 2t negative s. And then plus 2t. We don't really need to include the s because we know it's going to be, well, we could. We know it's going to be s to the 0 power, right? But, so whatever, doesn't happen. Same thing, we're not going to have, well, this is, yeah. We know it's going to be s, but we don't need to do the 2t because that's going to be to the 0 power. But anyways, so we start with 5. So 2t starts at 5, then goes to 4, 3, 2, 1, and our we showed 0. Our s starts at 0, goes to 1, 2, 3, 4, 5. Okay? So that was the relationship that we already talked about that we learned on our binomial expansion. So now I just need to evaluate each one of my terms. So 2t to the fifth power, that's going to equal 32 t to the fifth. Because remember, you got to do 2 to the fifth power and t to the fifth power. Here we have 2t to the fourth, negative s to the 1. Well, since negative s to the 1, that's going to be a negative. So I know my whole answer is going to be negative. Then I have 2 to the fourth power, which is 16, times 5, which is 80. So I have 80 t to the fourth s, right? And the negative sign I just wrote in front. Here, negative s is squared, so now it's going to be positive. T cubed, and then 2 to the third power is going to be 8. And then 8 times 10 is going to be 80 again. So I'm going to have an 80 t cubed s squared. Here my s is going to be odd, so therefore my whole term is going to be negative. And then I have t2 squared, which is 4. 4 times 10 is 40. The next term I have negative s to the fourth, which is going to make it positive. And then I have 2 times 5, which is 10. And then on the last one, I have s. It's a negative s. Negative s to the fifth means it's going to be a negative. And then I just have s to the 5th power. So there you go. That's your binomial expansion. Or you guys can multiply that number by itself 5 times if you want to, Hunter, without talking